Hey guys, Felipe here. So in this video, I'm going to be talking about merge sort algorithm, which is one of the sorting algorithms, probably one of the worst ones. So not one I've used, right? But it's good to know, and I like knowing how this stuff works, right? So I'm going to jump into it and kind of explain what merge sort is, right? So merge sort, right? I got a quick clip here that kind of shows how it works, right? The actual algorithm, what it's doing under the hood. So it basically, it's going to take in a collection of unsorted elements, right? Numbers. And then it's just going to break that collection into smaller collections until eventually it's just going to be one collection. And then it's going to compare two individual collections to one another and ask the question, hey, is this number smaller than the other number? And if the number is smaller, it's going to add it to another collection, right? So eventually it keeps doing that. And then you have a fully sorted collection from the initial collection it receives, right? So that's basically what the algorithm does. So here you can kind of visualize what it does under the hood. It's pretty cool stuff. So it takes a big collection and then eventually it outputs that same collection in a sorted manner, right? From smallest to largest. So this little clip here kind of shows how that works. I find this to be pretty cool. Sweet. So there you go. Boom. Fully sorted the initial collection. So what if we have a big list of unsorted items? Well, we just break it into smaller items, right? Or smaller lists of those items, right? But at this point, we just have a problem, the same problem, just smaller, right? So let's break those each into smaller lists and try again. Eventually, we're going to end up with a list which just has one element or no elements inside of it. And by definition, that is a sorted list, right? So that kind of sounds like a base case for recursion. That is kind of what we're going to use here, right? We're going to use recursion, which is just piggybacks off of the last video I made. So, okay, so we have two sorted lists. What if we merge them back together in a way that we're sorting as we go? We'll take those two smaller sorted lists and combine them back into one larger sorted list. And then we'll do that with the bigger list until eventually we've merged them all back together into one fully sorted list from the original list that we got that was unsorted, right? So we'll use two functions in this case. One of the function is just to break the bigger lists into smaller lists through a recursion call to the second function. And that's basically we're gonna use here, right? So I kind of give another visual example here. I'm not gonna go through it, but just basically gives another visual representation of what goes on under the hood, right? So basically I'm using two forward slashes to basically show you that everything after the two forward slashes isn't being called. And then I'm using a dash dash def with a number to show you how deep we are in the actual call stack. So you kind of see here initially the function receives a unsorted list. It breaks it down in halves, and then it just simply asks the questions eventually until it breaks it down into one element per list, and then it's going to compare those single element lists to one another and ask a question, hey, is this number smaller than this number? And if that's the case, it's just going to add it to another list and then eventually concat them together, right? So you kind of quickly see here how that works in another visual representation under the hood, right? So it just keeps going through that until eventually it returns the fully sorted array, right? Or sorted list. That's basically the end output. So what is the big O? Pretty much merge sort is pretty bad performant or not the best sorting algorithm. So every case is the worst case. This, no matter what, is going to break down that original list into smaller lists until eventually it's just a list of one individual element, and then it's going to compare and concat those elements together from smallest to largest until eventually it outputs a fully sorted list, right? So for merge sort, all three of best, worst, and average case computational complexity, the answer will be the same. So it's always the same. It's always going to break it into individual arrays of one element. So let's talk about big O then. Every item in the array will be looked at least once. So that means that we're going to be at least O of n. Then we need to compare those items to other items in the array, but how many times does it diminish as the list gets longer or not? It turns out that it does. Notice that the 1 in our example never gets compared to 7 in the array. Basically, when we break the array down into smaller pieces, the 7 gets put in a group with 4, and the 1 does get compared at one point to the 4 and gets sorted before the 4. So basically, by virtue of that, anything after the 4 is larger than the 4. So we don't need to compare the 1 to each of those numbers. We can take shortcuts in this case. So this is the hallmark of log n sort of behavior. The larger the list gets, we get diminishing amounts of more things to do. So let's combine our two terms together. The sort's computational complexity is O(n) log n, right? And that's the best, worst, and average case. For general purpose sort that we're going to get, right? So this would definitely get significantly faster, or is significantly faster than O(n) squared, right? What about spatial complexity? Notice we're creating and throwing away a lot of arrays because we're breaking literally every element into its own individual array and then throwing away empty one as we concat them together, right? So this isn't free on a large list. This can be a problem. Merge sort is among the worst because we'll create an array for each element in the array. We'll create an array for each element in the array plus a few more, which would be a coefficient. So big O wouldn't care. So the spatial complexity is O of n. Sweet. So now let's actually visualize and see how this actually works, right? So I'm going to swap to the terminal here, and we're going to see it in action, right? So I'm going to just create a file called merge sorts, and then I'm going to spell the hell out of that command. So we're going to make this file, right, called merge sort. We're going to enter that file, and it's just going to touch. We're going to make a well, inside of this directory, we're going to make a file called merge sorts.js, and we're going to do a quick npm init-y, so we don't have to answer all those questions, and so we can use Node, right? So we can run the actual file. Sweet, let's jump in, boom. Okay, so we're going to need two separate functions, right? One's going to break the list down into smaller lists, and then the other one's going to basically compare the items in the broken down list and concat them and return them in a sorted manner, right? So we're going to need one function, and we're going to call this merge sort equals, and we're going to pass in a collection, right? Or a list or an array, whatever you want to call this thing. We're going to have a base case, which is what ends the recursive call, because otherwise you have a never-ending chain of function calls, right, which would be bad. We're gonna, so the base case would basically be if the length of the collection that just got passed in is less than 2, we're gonna just return it, right? So we're gonna return that, right? And now we're going to break that list down into smaller lists, right? So first and foremost, we're going to get the length of that actual collection, right? So we're going to get the length of that collection, and then we're gonna break it down into left and right. So we're gonna get the middle of it first, the actual center of that collection. We're gonna use math.floor to make sure it's a whole number, right? Because we can't work with floats or decimal numbers here. So that's just basically the length divided by 2. So we're splitting it in the middle, right? And now the left side of the collection is gonna be the nums dot slice. So we're slicing from the first element to the middle element, to the middle, basically, right? And then for the right side, all we need to do is slice the middle, right? So it'll be sliced from the middle to the end, right? So we just pass in middle here. Sweet. And now here we're gonna do the recursion call. So we're gonna recursion. We're gonna call the other function passing on the left and the right side. So we're gonna call that one merge. And we're gonna pass in the left side of the list and the right side of the list, right? Sweet. Close that off, boom. All right, fix this typo here. Boom. All right, so that's the next function, which I just kind of named over here, is gonna be called merge, right? And then merge is gonna get the left side of list and the right side passed in. And this is where all the sorting is actually gonna happen, right? So we're just gonna create a variable called results, which is gonna be an empty list. And this is basically where all these sorted numbers are gonna get pushed into once they're compared, right? So we're gonna use a while loop for this. So while left length is so while left length and right length. So while there's actual elements inside of the collection, right, we're gonna run this loop. And then we're just gonna compare is left first elements in the left collection, is it less than or equal to the right first elements or elements in index 0? And if so, we're just gonna push that into the results empty array we have above, right? So that's where we're collecting all these sorted numbers in, basically. I'm going to use shift here. Basically, shift is the opposite of pop. It gets the first element in the array and it returns it. So it's just the opposite of the pop array method. All right, sweet. So if that's not the case, then we're gonna push the right one into the results empty array, where we're collecting all these sorted numbers. All right, so got that going there, boom. And finally, we're gonna return that results, that array, that array above, we're pushing all these sorted numbers into, and then we're gonna concat the left and the right into that one result array, right? So we're basically just basically adding them all together into one collection that is sorted, right? Okay, what is this? So no, this is supposed to be out here. So that's supposed to be out here, and then just missing this thing. There we go, boom, delete this thing here. All right, so I'm just gonna create now a list of unsorted numbers that we're gonna pass into that merge sort function, right? And then it should spit out the same list, but in a sorted manner, right? So I'm just gonna do 10 all the way to 1. And then it should just return 1 through 10, right? So I'm just gonna log this stuff. console.log so we can see it when we run the file and pass in this collection. Sweet, so cool. Let's see if this works. Node merge sorts, results not defined. What did I do here? Results because it's named wrong. So I just got to change this here and add yes here, and boom, should work now. Okay, sweet. So we gave it an unsorted list and then it returned a sorted list, right? So that's just basically what merge sort does. Sweet. So if you guys got some value from this video, please like and subscribe. Leave a comment so we can learn this stuff better together, right? Thank you guys for watching, and I'll catch you on the next one. Have a good one.